Hey, I'm 218. It's time to talk about probability. So my guess is somewhere growing up that you've probably seen this before, that probability is the number of winners over the number of possibilities. Maybe instead of winners, they said the number of successes over the number of possibilities or the number total. But my guess is that you've seen this fraction here before. Okay, I'm going to start with a real basic junior high example. So let's say you have a jar of marbles, and in that jar of marbles you have 5 red marbles, 3 purple marbles, 2 yellow marbles, 4 blue ones, and 1 green one. So if we add those up, 5 plus 3 plus 2 plus 4 plus 1, what do we get? We get 10, 14, we have 15 total marbles. Okay, so if I ask you randomly, you can't see in the jar, stick your hand in the jar and pull out a marble, and what is the probability that you pull out a blue marble? So what is our fraction going to look like? Our fraction is going to be the number of winners. So the winners would be the blue marbles, which would be this one. So the number of blue marbles, which is 4, over the total, which is 15. And it can't be reduced, so we leave it just like that. Okay, I can do the same thing for the next one. So what's the probability of getting a green marble? Well, there's only one green marble in the whole bag. That's that one right there. So I have one chance at a winner, and I have 15 total. So my probability of choosing a green, 1 out of 15. Okay, now let's look at that next example. The next example says, well, what if I ask for the probability of purple or yellow? Okay, what does that mean? That means that now these purple marbles are winners and these yellow marbles are also winners. So I have to add these two groupings together and say I have 5 total marbles that would be considered winners over 15 total. And this one does reduce, so we should always reduce our fractions, and I'm going to get a 1/3 as my answer. Okay, last example here, or last part of this example, what's the probability of choosing a black marble? Well, when I look at my list, I have red, purple, yellow, blue, green. I don't have any black marbles. So the probability of picking a black marble is 0 out of 15. Okay, and because we're good mathematicians, we would never leave our answer like that. We could look at that and we could say, well, what is 0 out of 15? How does that reduce? That's just the probability of 0. There is 0 chance of choosing that black marble. Okay, let's look at a geometry example. So here I'm giving you a number line. Okay, so the thing about a number line usually has all these tick marks on it for usually all your integer values. I'm not doing that. I'm cutting it off, and I'm only putting a couple points on here. I'm putting point A at 2 on the number line, point B is here at 10 on the number line, and point C is here at 13 on the number line. So I'm asking you to find the probability of choosing a point on AC. So only starting there, ending there, nothing over here or over here is relevant. So choosing a point on segment AC that's within 5 units of B. So at first this question looks very, very easy, but there's actually quite a few levels to it. So first, I'm going to figure out, well, what's within 5 units of B? So within 5 units of B means I can go to the left and I can go to the right of point B. So here's B. If I go 5 units to the left of B, I'm going to be over here at, let's say right there, that's where 5 is. Okay, if I go 5 units to the right, I'm going to be over here somewhere at 15. Well, clearly, this part over here can't count. It's not on my number line. I have to be on AC, remember. So that means I'm going to actually cut this off at point C. So it's going to go from 5 to 13. That's my winning section. So how many points are in there? The biggest mistake everybody was going to do is going to say 5, 6, 7, 8, 9, 10, and they're going to count points like that. But let me actually draw some on here. Let's say there's 6 and 7 and 8 and 9, and then we've got here at 10. Okay, here's the problem. Who says that points have to be at integer values only? There's a point right there. That's a winning point. Here's a point right there. That's a winning point. Maybe 7.1, maybe 7.8, maybe 8.00001. Those are all points. Okay, they are all in the winning section. So how do I count every one of those points if there's an infinite amount of points? So even though this question says choose a point, we're going to actually have to deal with length. We're going to have to deal with, well, what length is a winning section and what is my total length? So if I go back to the purple, this is my winning section. My winning section starts at 5 and goes all the way to 13. So my winning section has a length of 8. How did I get that? Easy. I went 13 minus 5. Okay. AC is my total. So my total goes from 2 to 13, or from 13 minus 2 gets me a length of 11. So the probability that I choose a point in the winning section, and the winning section is within 5 units of B. So the probability that I choose a point and it's going to fall in this range, but it's on this whole segment still, is going to be 8 out of 11. Okay, last example. So let's again randomly choose a point on the diagram. And what is our diagram? Our diagram's an angle, vertex at B. So randomly choose one of the given points. So the points are A, B, C, and D. Choose one of those points, and what's the probability that the point happens to fall on this ray right here? So again, we need to know how many points are my total. I have 0.1, 0.2, 0.3, and 0.4. That's my number of possibilities. When I stick my hand in the bag or wherever I'm choosing them from, I have 4 possible points I can choose. Of those points, how many are on ray BD? Well, I have B, C, and D. Those would be my 3 winners. Okay, A would not be a winner. So I have a 3/4 chance of choosing a point on BD. Okay, that was easy enough, but let's get to part B. You didn't need me to explain to you part A again. I put part A in this problem so we could see the difference between part A and part B. Okay, the difference being part A we choose 1 point. Just like when we stuck our hand in the bag of marbles, or the jar of marbles or whatever it was, we chose 1 marble. But what happens if we're going to choose 2? Choose 2 points, choose 2 marbles, choose 2 segments, choose 2 whatever. Okay, anytime it says choose 2 or choose 3 or choose 4, if it is not choose 1, then you need to make a list. We need to list out all of the possibilities of options. So how can I choose these? I'm going to try to be organized about this. I could choose point A and then point B. I could choose point A and then I could choose point C. I could choose point A and then I could choose point D. Okay, maybe I don't choose A at all. So maybe the first choice I have is point B and my second one is C. Or maybe I choose B and then I choose D. Okay, maybe I don't choose B at all. So then my next option is to go point C and point D. Okay, I am not going to list them in reverse order. What if I choose B and then I choose A? What if I choose C and then I choose A? Okay, choosing 2 points, the order's kind of irrelevant here. It doesn't matter if I choose A first or B first. It's the same grouping. So I could list all of these in the opposite order and go BA, CA, DA, CB, DB, and DC, but everything's just going to double and it just reduces down the same. Now, if this had said something about array or something where the order does matter, then I'd have to list the possibilities both ways. But on this one, I do not have to. So now here's what I've got. I have 1, 2, 3, 4, 5. I have 6 different ways that I can choose 2 points. So now I have to look and say, well, who are winners and who are losers? Okay, my options have to include B, C, and D. Anything including A is a loser. Loser, loser, loser. So when I look at this, okay, BC, that's a winner. Those have 2 points on the winning ray. BD, that's a winner. It has 2 points on the given ray. CD, 2 points on the winning given ray. So my winning choices are 1, 2, and 3. 3 of my 6 ways that I can choose 2 points end up giving me a winning solution because it gives me 2 points that both fall on the right ray. And of course, we're going to reduce that to 1/2. So the key on this problem is that anytime it says choose 2, choose 3, choose 4, you have to make a list. Okay, next year when you get into a whole unit on probability, they'll start showing you shortcuts. But for our curriculum's sake, it is important that I am responsible to teach you how to list out your options and then be able to choose winners and losers from those options. So you must list out all the possibilities of whatever it's asking. Choose 2, choose 3, choose 4. Anytime you see that, you need to make a list. In our class, you will not get any partial credit if I do not see a list. Even if you get the right answer, okay, I can't give you full credit unless I see that list. So make sure you understand where that list comes from.